Simplify the following rational expressions. 10 plus the quantity a plus 6 over a minus 4 by a plus 6. Now it might be tempting to, cross out those a plus 6's. But wait a second, they have to be factors. And that a plus 6 is not being multiplied by 10 in the numerator, it's being added. So we can't remove the a plus 6's because they are not both, the a plus 6 is not a factor of both the numerator and denominator. Instead, what we can do is combine like terms in the numerator. 10 plus a plus 6 is a plus 16, and the denominator is still a minus 4 by a plus 6. We can't factor the numerator, and the denominator is already in factored form, and we can't remove anything, so we generally leave the expression as that. A plus 16 over a minus 4 by a plus 6. Looking at exercise B, we have m squared minus 6m plus 9 over 3 minus m by m plus 4. All right, well, I can try and factor that numerator. M squared minus 6m plus 9, using factoring techniques, yields m minus 3 by m minus 3. And in the denominator, we still have 3 minus m by m minus 4. All right, we look at that and say, well, I don't see anything that I can remove. But wait a second. What if I switch the order of the terms in that first factor, that in the denominator, that 3 minus m? So what if I wrote that as, let's see, m minus 3, m minus 3, and in the denominator, instead of writing 3 minus m, what if I wrote negative m plus 3? Now notice, when I write it like that, and remembering what we've done in the past, we usually like to have that lead coefficient, that first coefficient, if the polynomial is in descending order, we like that to have a positive coefficient. So what I'm going to do now is leave the numerator alone for now, but that first factor, that negative m plus 3, I'm going to factor out a negative 1. If I factor out a negative 1, I would have an m minus 3, and I'd still have the m minus 4. So now notice that there is a common factor between the numerator and denominator. So remove a common factor of m minus 3, and so now I have m minus 3 over, then I have this negative 1 by m minus 4. Now, there's nothing wrong with this, but traditionally what we do is, if we think, okay, well, then we have that m minus 3 over a negative quantity m minus 4, we sort of have a positive divided by a negative, and what we usually do is we just write that negative out in front of the fraction. We have m minus 3 in the numerator and m minus 4 in the denominator. Exercise C, we have 2x plus 14 over 2x squared plus 17x plus 21. It's not obvious that there's any common factors here, but to see if there are actually any, we have to do some factoring. In the numerator, I'll just use the GCF method. 2x plus 14 is the same as 2 times x plus 7. 2x squared plus 17x plus 21. Let me do a little side work here. Let's see. AC method, 2 times 21 is 42. So we need to find a pair of numbers that multiplies to 42 and adds to 17. 1 and 42, 2 and 21, 3 and 14. 3 and 14, that's the pair of numbers. So I've got 2x squared plus 3x plus 14x plus 21. And I'll use grouping now. So let's see, that is x by 2x plus 3 plus 7 by 2x plus 3, or 2x plus 3 by x plus 7. So the denominator factors as 2x plus 3 by x plus 7. And now I can clearly see that I'm allowed to remove the factor of x plus 7 from both the numerator and denominator, leaving 2 over 2x plus 3. Can we remove those 2's? No, we can't, because 2 is part of this term, the first term. It is not a factor of the entire denominator. So we would leave this as 2 over 2x plus 3.